Hey, hello, and welcome to the show. It's me, John Park. It's time for John Park's Workshop. And I'm just having a good laugh because I posted over in our Discord chat, which is right here at adafruit.it/discord in the live broadcast chat channel. I had posted a little icon of coffee, and it's a terrible icon. Look at this thing. It looks like, as I say, a couple of worms that are gloating over the fact that they've ruined your coffee. Except, our friend Steve, OK, you're on, pointed out that on your phone, it looks great. The Discord client on the phone has a beautiful coffee cup. I didn't really think about the fact that iOS versus a browser-based solution for Discord has totally different emojis. What the heck? But Steve, I don't know, he made me happy with that boba tea, so that's something right there. Also, hello to the good people over in our YouTube chat. If you're wondering where all these chats are happening and you're somewhere like Twitch or Facebook, I can't watch all the chats, so mostly I'm here on our Discord, right there, and checking out our YouTube chat. So thanks everyone for stopping by in those places. Let's see, what else is up? Hello to my friend Kurt, if you're watching. My friend Kurt may be watching, and I don't know if he normally watches, but Kurt, hey, hope you're watching. Let's see, what else is going on? I got back from a vacation. We went to London. And among the other cool things that happened there was my wife spotted this T-shirt at a little shop we were at in where was it? In where all the vintage clothing is. What's that neighborhood there? I forget now. Anyway, she found me this shirt that's got all of the London Underground as a cassette tape and a bunch of music styles, which I dig. Shoreditch. It wasn't Shoreditch, but near Shoreditch. I can't remember. Hey, Mark Devink. Mark Devink is over in our YouTube as well. Nice to see you, Mark. Does everyone appreciate the fact that Mark has been making these amazing LEDs that we're selling now over in the store? Check these out. Deluxe Delight. This is a cat, and it's an LED. Look at that. He's got a whole bunch of them. Do we have a link that's all of them? Let me see. There's got to be. Surely there is. How about Deluxe in our search? Look at these cats. A couple colors of cats. 3 colors of cats. A little aloe vera. It's a little succulent kind of guy there. Some skulls, crystal, cone, sphere. Awesome stuff. So, way to go, Mark. Thanks for sharing those with the world, and go buy some. If you're looking for something fun to throw in your cart, you can get a little 3-pack for $9, $10, depends. How are you making those, by the way? Is this 3D printed resin? Is that what you're doing? Did you make a mold? I don't actually know how you're making these, so please let us know. We want to know. All right, what else? Let's see. We have a job board. If you're looking for work or if you are looking to hire someone, head on over to jobs.adafruit.com, and there you can join in on the fun. Let me go there right now in my browser and share that with you. Here's jobs.adafruit.com. It looks like that. You can search through here if you're looking for a particular job or if you're looking to hire someone with a particular skill set. Head on over here. It's free to use. All you need is to sign up with an email address. We promise not to spam you. And all of these are vetted with the utmost of care by L'Amour and PT. So presumably all legit. I don't know what guarantee we have on that, but that's a presumption, right? Jobs.adafruit.com. Go check it out. Also, let's see. I'm keeping an eye on the chat because maybe Mark will let us know how he's building those LEDs. How are you making them? They're great. So, Bornock said Spatial Fields Market? No, what the heck was there was a, begin with a B? This was just days ago and I've already forgotten. Pardon me. All right, I'm sure it'll come to me or someone who knows London well. So what else? I've got a show on Tuesdays that some of you may have caught. It is called JP's Product Pick of the Week. That's the little logo right there. And on the show each week, I like to show off a cool project, or rather product. This week it was this NeoPixel 332 per meter strip. It's a half meter, so about 166. And I'll do a little bit of a demo. We got a half price on this during the show. No coupon code needed. You just buy it and it's cheap. And I will show you a little recap of it. The NeoPixel 332 silicone bead LED strip. It is a half meter, so there's 166, I believe, LEDs in there, and it is gorgeous. So this is individually addressable NeoPixel LEDs. I've plugged it into a QT Py RP2040 with a little battery BFF and a little LiPo battery. And as you can see here, you get a really nice, nearly solid display. You can see as they dim there, they will start to reveal the trick, but at more moderate brightness levels, and this is only at, I think, 0.35 on brightness, it almost looks like a continuous neon strip, except it's got this individually addressable RGB effect to it, which is really cool. That is my product pick of the week. It is the NeoPixel 332 silicone bead half meter LED strip. All right, I remembered. It was Borough Market. That's where we were. This was really important to remember this. Borough Market. Got some good cheese there from a cheesemonger, too. That was the question, Mr. Certainly, if you were wondering still. All right, let's see. What else is going on? Hey, this is a great time to do a little Circuit Python parsec, where I'll give you a little tidbit of how to do a certain thing in Circuit Python. So check it out. Circuit Python All right, let's do it. Let me just find my coding window there. Okay. For the CircuitPython parsec today, I wanted to show how you can use the pixel map inside of the LED animation library to separate a NeoPixel strip into different logical groupings. So one physical strip, multiple logical groupings. It allows you to do some really neat stuff and essentially in code treat this like it's two strips. But you can see here, I've got one ring here. It's a ring of 24 NeoPixels. I have a little diffuser on there to make it a little easier to look at under the camera. And I'm using two separate Comet animations running at different speeds with different colors, treating it like two strips. Not four, but two. Here's how we do it. In code, I am importing the board library to get pin definitions and the NeoPixel library. Then I'm bringing in three sections of the Adafruit LED animation library. I've got Comet, which is the animation effect that I'm using here, a couple of color definitions, purple and green, and then this pixel map business. So I set up the strip, and you can see this is the normal NeoPixel definition, so I'm just saying it's a 24 pixel strip on pin A1, and I'm setting the brightness pretty low, 0.05. Then I set up these two logical pixel map groupings, LEDs range A and LEDs range B. You can name those whatever you want. And in there I use the command pixel map LEDs, which is the NeoPixel strip. The range that I'm using, the first one goes from 0 to 11, and then the second one goes from 12 to 23. You just tell it the outer bound number there. And then I'm setting up a couple of these different animation objects for Comet. Then I fill the whole thing with black, so it turns them all off. And then the main loop of the animation just simply says, run those two animations. So any changes you want to make to one of these, you can do it, and it doesn't affect the other one. And so that is how you can use Pixel Map in the LED animation library to set up multiple logical groupings of NeoPixels on a single physical strip. And that is your CircuitPython parsec. Wow, wow. CircuitPython parsec. All right, and thanks again to the creators, Rose and Katney in particular, but also others on the CircuitPython team for making that LED animation library. If you haven't used it, check it out. There's so much you can do with it. I'll do a few other tips with it. I've done some, I think, in the past. I've also done some projects like the revised version of the Lucio Blaster. Pew pew. It's over there, but I'm not going to get it right now. That uses the LED animation library to make life really easy to set up some really cool effects. All right. Let's see what else is going on. Hey, there's a cool, what's this cool animation all about? Yanisku, little GIF there. By the way, a Discord tip, there's a setting where you can tell it not to autoplay animation so it doesn't like distract you until you mouse over. I use that, but you can tell it usually says GIF in the corner, I think. Let's see, what else? Oh, thank you, yeah, DJ Devin3 said nice demo of the composite video nubshank in the monitor in the background. That's that Dali clock with the vaporwave action going on there. And I think it's still in pretty good time. I'm not grabbing it off the network regularly. I just set it up once, but the thing actually keeps good time with its own timer in the microcontroller. Let's see. Rich Sad says, I have a number of questions about advanced use cases that I don't see how to support. Yeah, that is, if you're talking about LED animation library, that's the thing. It's got a bunch of pre-configured things with some settings you can tweak on them, but some stuff you just can't do unless you get that feature added to the library. So it's not NeoPixel itself and then coding things, maybe even using async I/O. That's the way to get really exact stuff, but you can get a lot of really cool effects based on sort of those pre-canned effects and a few knobs that you can twiddle on them. For example, one I've seen with Comet, and maybe someone else knows how to do that, but if you look at my downshooter here for a second, you can see I've got this purple Comet there, and I've set the tail length and the speed and the direction. I'm not having it bounce. But I don't really know in LED Animation Library how I could have like multiples of them coming like one after another. Maybe it's possible, but it's sort of, by definition, trails everything all the way off before it starts the next one, and I think that's just the nature of it. It's a convenience library, but it's not going to make every possible thing you can imagine possible. Let's see. What else? I think that is it for stuff going on over in the chats. So what I wanted to do next is, this would be a cool time to do a bit of a gear report, and then we'll get into the main project. So let me go grab something off the workbench. I'm going to do it right here, just because I'm out of space over on the workbench. This is another London-related thing, actually. Let me grab, so I'm grabbing my iPad here and dropping things. Let me see. That, let me put that on a little stand so it's at an angle. Hold on one second. Oh, that's terrible. Okay, well, it's going to be smudgy and reflecty. But hey, let me pause that. So this is what I wanted to show off. I was able to meet up with Tom Whitwell when I was over in London. Tom, as some of you who are into synthesizer-y things or music things might know Tom and his company Music Thing Modular. And this is a really cool little riff on the 16N fader bank that he calls the 8MU. And it is, as you can see, 8 little faders. It has an ATSAM-D21 in there, and it is running some Arduino code. I think at first he was doing some stuff in CircuitPython with it. You could probably get CircuitPython back on it, but for the responsiveness he was looking for, he went with Arduino on this. And it has an IMU in there, so it can do some tilt control things, and it can use these faders as well as some really neat little sort of side-mounted buttons. USB-C connector there. It's designed to send MIDI messages, MIDI CC messages or MIDI notes out. It's configurable both with some presets on here as well as in code if you want to flash it with new firmware. And I just wanted to do a little demo of it because I found this is really cool for iOS music stuff. So if we jump over to the down camera here, and you can see here I have a version of sort of a fork of VCV-Rack called MiRack or MiRack, and these are little virtual synthesizer modules. What I'm going to do is connect up one of these little Apple on-the-go camera adapter thingies, and then over USB-C I'm going to plug in, let's see if I can put it in that way, plug in the little fader bank, M8MU, and actually let me plug, I think the order you plug it matters for iOS to recognize this. Okay, let me try the other way. Uh-oh, bad demo. It's not responding. Oh, I'm not playing, that's why. There we go. Okay. I keep forgetting this. This is not something that MiRack, which I use a lot more, has, which is or at least it's not an obvious place like it is on the iPad here. This is a pause button. You can pause the entire synth. It's not just the audio, so it just stops visually responding. So the idea with this is that if I'm using this the traditional way, I'm going to go in there and nudge these little sliders around, which is kind of okay, but not great. But wouldn't you rather use physical sliders? So that's what the 8MU gives you. So I have 4 little oscillators with different clocks going in, and this is a little mixer. And so I can mix the audio levels of those as well as the harmonics. If you look at these little knobs on the top right of each of those 4 modules. Oh, and if this will work, I can also change the octave on a couple of them. Yeah, that just dropped. Let's go to that one. Am I clicking that button? There we go. Anyway, it's really fun to see physical sliders move on the screen when you move physical ones, to see the virtual ones go. So that's something that makes me happy right there. So thanks, Tom, for that. And he's going to be selling these via thunk.co.uk, which is the reseller for all Music Thing modular things, most of which in the past have been modules for MiRack. This is one of the first ones that's a standalone physical gizmo. Great job with this, and thank you, Tom. Tom, by the way, did a lot of really neat stuff in this build. Let me unplug this and set this back over here. So if you look, first of all, very thin PCB material for the top and bottom here to keep the height of the thing low. This is a notched USB-C connector, so it doesn't stand up above it. Made it easier to fit it all in there. This is the little side mount button here, so it can basically fit underneath this jack. This is a jack for classic serial UART style MIDI, which he said he's going to re-enable in some firmware that he'll send. And then more of these little buttons that are edge mounted. Really cool, and then some instructions on the back on how to use it. And like I said, you can change the modes by using these side buttons, and that allows you to do things like enable or disable the accelerometer-based stuff. I think there's a tap detection, as well as different arrangements of these banks. And I don't know if you can change MIDI CC numbers with those. I haven't messed with that yet, but really cool. So keep an eye out for that. That was a project I know has been a long time in the making, if you follow Tom on social media, and exciting to see it very nearly out, very nearly completed. So, all right, let's jump back into our main project then. Rich Sad asked, who made this? It is made by Music Thing Modular, aka Tom Whitwell. And if you have ever heard of a module called the Turing Machine, that's the one that people know Tom best for, one of the most popular modules, a random melody generator that's really cool. And you know, I would say of course you can use this for music stuff, but I've shown before these types of little MIDI faders are great for stuff like adjustments inside of Lightroom. If you're doing color correction in Lightroom, there's a great plugin that makes it possible to use MIDI faders to adjust things, and then you can permanently have like an exposure value, a gamma correction, some different color, white balance stuff, all at your fingertips with sliders, which is really nice. The firmware will be open source. Yeah, everything Tom does is open source, so I assume this is no different. I don't think it's published yet, but it will be. And like I said, this is a riff on another project that's also open source called 16N. I don't know what the N stands for in that, but N is in Nevada. 16N is a larger fader bank that uses a Teensy. But Teensys are hard to find, and this one's based on a, well, also hard to find SAMD21, but maybe not as hard to find. Don't know if there'll be a kit version, or if anything, you'll just do the assembly of the PCB to sandwich the thing, maybe solder on your sliders, I'm not sure. And I don't know if you could see it, but there are some surface mount LEDs under those that were glowing when it was on, which is cool. So thank you again, Tom, for that, and excited to have that in the arsenal. I was able to use that on the airplane, which is the perfect use. Oh yeah, so Steve says SAMD21 also very hard to find as bare chips. So I'm guessing Tom secured the amount that he needed for his first run of those, hopefully. Crossing fingers. The other thing, by the way, with stuff like that is you probably can, if you want to, you could probably code that to send out USB HID stuff, arrow keys, those sorts of things. So these types of devices are usually very configurable to do things other than just MIDI. All right, so now let's get to this project. So last week I was away. The week before that, I did a bit of an introduction to the general tape looping, cassette tape stuff, and multi-track stuff with a 4-track and so on. But what I wanted to do today is show you a specific use for this tape deck. What I'll do actually is I'll give you a little tour of some things here from my downshooter. So at the center bottom right-ish area, you can see there's a Walkman there that's partly opened up. And then I have some other gear there. There's a MIDI keyboard, so I can send MIDI commands out through this little USB MIDI hub called the RetroKits RK006. And that allows the keyboard and a QT Py to be hosted by a USB MIDI host, which means I can send MIDI commands from that keyboard to the little QT Py that's at the center of the screen. QT Py can turn those MIDI notes into voltage outputs for a DAC. So there's a little stemma QT cable there, and there's that little quad DAC. And then there's two mysterious cables running to the Walkman. So that is my speed controller. I'm essentially adjusting the speed of the motor in there with a range of, essentially, I've got about 2 octaves, I think. It's 2 volts, and I'm treating it like 2 volts per octave. I need to do a little more testing to see how accurate that is. But it seems like I've got about 24 playable notes on there, so it feels like maybe that's 2 octaves. And then I'm running some effects just so it sounds cooler, so we can hear that. So what I've done is I've taped a continuous sine wave chord onto one side of a cassette. So it's just going to play that, which is pretty boring, except once we can start changing the speed of the motor, we're essentially repitching this whole chord. And you could do that with anything. You could do that with a normal pre-recorded cassette. You could do that with just a single tone. You could do it with drums. But really, this continuous tone is a great use for this type of a mellotron, which is a tape playback with different pitches type of instrument. So it doesn't feel like it's speeding up and slowing down so much as it's changing pitches, versus if you were to put a drum beat or a pre-recorded song in there, it sounds a little more like you're just messing around with the speed. So let me go over there and demo some stuff and show you how this all works and where we're going with it. So let me switch my camera over to there and head on over. And by the way, if you're over in the Discord chat, Steve just posted a link to an article about a Mellotron, so go check that out. They're really cool. I believe a Mellotron has a discrete tape loop per key, so there's a whole bunch of tape mechanisms in there, so it's a little more like multi-sampled rather than one sample that's being pitched around. And I'm just going to open up Discord on my phone here and hope it doesn't turn itself off. You stay there. So DJ Devin 3 says, how do you figure out that a tape recorder could play back different speeds depending on voltage? Is that just a known thing? So this is a great question. I'm going to unplug this little Walkman here from the DAC and the QT Py. And what I'll do is, when I play, you'll see that this Walkman actually was designed as a dictation machine, and so it has a easily accessible potentiometer dial to change the speed. And this was usually used so that you could record notes, and then when you wanted to type them in later, you could play it slower so that you could catch it. So this one, and you'll find a lot of them out there, it has an external speed controller. I'm just going to zoom in here for a little bit so we can see things a little better. So you see here, variable speed playback. If you Google this, you can get these for about $15 on eBay. And this one I didn't even have to change belts on. It was just working. If you do, you can buy a little pack of belts. This is the most common thing to be broken in a Walkman, is this belt has deteriorated or turned to goo. Change that belt out and it's good as new. So if I play, I'm going to play back this tone. And let me turn off any effects. So that is what I recorded onto this tape. It's just a little sine wave chord. If I adjust the speed controller, you can even see this little pulley wheel goes faster as it's higher pitched, and it's going to slow down. Now it's in sync with my shutter rate, so it looks like it's almost wagon wheeling backwards. Okay, so that is on this somewhat special type of player. It's not too rare. The interesting thing, though, is here is a modern day, very inexpensive, like $10 to $15 on Amazon type of player. It's called the Byron Statics. These are really cool. It's very similar to this old GE in that it has a speaker in the door, so you can play low quality audio right there. It has a microphone on it, so you record. This one even has an AM radio in it. And it does not have an external speed controller, but you can tell I'm leading the witness a little bit there by saying does not have an external one. And that is because when these types of devices are made, they usually need some tuning with a trimmer pot at the factory before they go out the door. So someone is probably playing a tone, a known, let's say a A440 on a tape, and then adjusting an internal trimmer pot until it matches, and then you know when you get it and you play your pre-purchased cassettes, they're going to be in the right key. So that trimmer pot is hidden right here. You just kind of have to search around for them a bit. So you'd go in there with like a long, thin plastic screwdriver and just twist that to adjust the pitch. But since that has that, even though it's not external, it doesn't matter. We can still go in and either add a potentiometer, a knob or set of knobs. That's a popular way to do this type of hack. Or use either a digital potentiometer or a DAC, digital to analog converter, to send voltage, and we'll hook up ground as well, but to send voltage to that wiper. So it's essentially a way to digitally adjust what that motor's voltage is. And as that motor's voltage is adjusted, it will change the playback speed. Generally, I believe you're safe within 3 volts. Usually a little less is what you're going to get from the adjustment wheel. So we can see on this one here, let me try to move things in focus just a little bit better. Oh, we had it. There we go. Okay. So on this one, this is the wheel right here, so it's really easy to find. Let me grab a pointer. And so what I've done is I've gone in and soldered in a little cable with a connector pin on the end to ground. And then I've got the essentially the wiper pin of the potentiometer's connection here, which is labeled on this one as VS plus, which is I think variable speed plus. That's what varies the speed of the motor. So if we take these and send different voltages to them, anywhere from 0, which means it should be unchanged from what this thing's default is, up to, I could probably do about 3 volts, 3.3 volts with the QT Py, since it has 3-volt logic. But what I'm doing actually right now is this little DAC. It's a quad DAC chip. It uses the MCP 4728, and it's connected to my QT Py microcontroller there with a stemma QT cable. This has 4 DACs on it, and so that means it can send 4 separate voltages. So I connect ground right here, and I connect that wiper variable voltage to the A, voltage A out, so there's A, B, C, and D. It's possible there could be other things on here I would want a voltage control, but probably not, and I just happen to have this quad DAC. You could use a single DAC. You don't really need one this fancy. And so let's go ahead and check it out. So what's going on is when I send MIDI notes from this keyboard here or from a computer or a sequencer, any way you want, when I send MIDI notes within a certain range that I determined is good to go, so 0 to about 28, 29 I think is the top MIDI note I'll allow, I then convert those into little millivolt outputs for this DAC. And let's go ahead and start the tape. So let me rewind it a bit actually first. Okay, so this is just droning on. Hopefully you can hear that well. Let me go check my chat actually before I go any further to make sure people can hear. And so this is a dry signal. So this is just the sound of the tape going to this little amplifier over here. And now when I press a key on my MIDI keyboard, it is sending a command via this little USB hub to the QT Py. So they're both being hosted as USB MIDI. And then the QT Py says, okay, what MIDI note came in? What should I change the DAC output value to? So it's just changing that voltage that's on that center wiper of the motor controller. Now, this is really responsive, which is cool. But since it's a physical device that has to ramp up, it's not instant, it's not some super quick stepper motor, it's just a cheap little DC motor, as far as I know, we'll get some portamento or glide effect. You hear woo when it gets up. It goes down quick. It can slow down faster than it can speed up. Whee, you get that really cool. And since this is MIDI, and I'm terrible at playing the keyboard, what I can do is I can create sequences with the sequencer of the keyboard or just send an arpeggio. So that's what I'll do now. I've got a little held arpeggio mode on here. I'll hit play, and then I'll set it in ordered mode. So whatever order I press keys and let go, it's just going to keep playing that little order of keys. Okay, so I've now, let me boost that volume a little. I've got a quarter note time division based on the rate, so I can just slow down that rate there. I can adjust the subdivisions. And check out how fast this will go. This is incredible that this little motor is that responsive. Get a little confused by it. You can almost make it act like a wavetable oscillator. If you get going fast enough, it'll start to become kind of its own funky harmonic tone. So now let me go back to a slower speed on this, and then I'm going to do some little effects on it. This adds some frequencies that this little amp isn't loving. So let me. I'm going to turn off my AC for a second just so I can hear this a little better. Let me stop the arpeggio. I'll show you the full range of this too. Let me change which. There we go. It's a little more for reverb. So I said this last week, any of these type of tape things you do, like so many things with music, sound much better going through some reverb or other effects. So I said I would show you the range. Let me take the effects out. So that's the lowest. This is sending 0 voltage, essentially. And then we can go up through the little semitones. I don't think I'm sending notes higher than that. Now this is just one choice of source material to use on this, so let me hit stop on that for a second. I'll take the effects out. I can't remember what I have on the other side. I think I have like a sawtooth wave. So you can see I've just taken cassettes and recorded like 15 minutes or 30 minutes of something onto there. Or nothing in this case. Let's see. There we go. So, oh, where'd it go? Did I record over it? I might have. Let me, we'll at least let that play for a second. It's gone now. I recorded over it. So now what happens if we do take a look at some pre-recorded stuff? So here's a mixtape that's got like some Depeche Mode or something on it. We'll get a copyright strike if we don't be careful, but. I'm sorry, but I can't find the right things to say. You know that song, right? All right, so we'll stop there before we get arrested. So yeah, like I say, I don't love that effect so much as just something prepared for this particularly to be a held tone. Same with drums; they just sound like they've been yanked around a bit. So that's the basic process, though. Take a cassette, record some long continuous tone. Last week I showed you can also make tape loops. This one's falling apart, which is the problem with tape loops. They like to come undone. You can make a tape loop. Oh, good. Now it's a Mobius strip, so that's no good. You can make a tape loop. Some people actually do that intentionally, like double-sided. It doubles the length of this. Might be like 10-second loop or something with a twist in it. It'll potentially. I think you can record to both sides of it. Don't punish me if I'm wrong on that. I might be wrong on that. I've never tried that. But these are pretty finicky. These tend to ask a lot of a cheap Walkman, and they're easy. Some of them won't run when the second wheel is not in there. I was just talking to Liz Clark, who's also working on some of these tape projects, and she added back one of the little wheels into there, and her Walkman was happier to have something else to grab and spin. But it's, there's a capstan roller that goes and grabs and twists here, and it's not so easy. This one I put a little rubber wheel made from a rubber band in there to try to give it some friction, and maybe that's what it doesn't like. But anyway, that's a tape loop. I don't necessarily need that for what I'm doing here because I can just record a continuous thing, and it can have some character to it. You could even put some shifts and changes and warbles in it, or even some key changes or chord changes, root changes. But the continuous one is a really great way to figure out what's going on with the cassette itself. Let's see, what else? So I've got this open right now for looking at it, but what I want to do ultimately is make this somewhat neat and contained. So let me get this battery out that doesn't want to come out. So my DAC needs to plug into these two cables here. So what I'm going to do is see either if I can run those through an existing hole in here, or if I have to drill, I will. This little battery compartment here, zoom in again, has a couple gaps in it. So if I feed these through here, I was able to get these through and still use the battery, which is nice. You can also gain a bunch of space to put stuff if you want to run this off of the DC power instead of battery, which is nice because then you're not wasting batteries, and it gives you all this space to put your electronics in. So you could potentially just have the MIDI jack, the USB jack for MIDI here, and you could fit that cutie pie and that DAC in there, no problem. If I do want to run this like that, I don't think I can close the battery compartment all the way, but I was able to get those batteries back into there and contacting that little spring. And this will kind of go halfway down. It basically closes. My wires are a little thick there, but if I go in and grab a couple screws, get it most of the way closed. A couple other mods you can do on these. There is the microphone input, because this one's a dictation machine. You can record onto it. It has a little mic in, so you could, if you wanted to do your recording on here as well as your playback, you could also do variable speed stuff while you're recording, which is kind of funky. You can hook up a little couple wires to where that mic is connected. You might need to disconnect the wires or add of the original mic, or add a switch for that. But then you could use an input of some kind. I'm not sure what the level of it'll be. And same with output. I'm just using the headphone out on here. Some people like to get a line out that's not going through the little headphone amplifier. So you can find, I believe, where these speakers are connected. You could, this little speaker here, you could send a line out cable. So there's lots of fun that can be had there with modding that. But now, with a little more put together, I can reconnect to my DAC. Put a tape in there. Let's rewind a bit. Before I put the sine chord, I just put a straight sine wave on there in the note of C. And it was not as interesting sounding to me. It didn't have enough character compared to putting the little chord on there that I put on. And let's plug our headphone out. Oh, it's not responding. What did I do wrong? What did I break? You're still talking to that. So you can see here I've got MIDI messages coming when this lights up. Let me just reboot the cutie pie. By the way, the cutie pie, rather the DAC, this little DAC board, it has a cool feature of a little EEPROM on there that you can write a value. So if you want to, you can write a DAC output of 0 so that it doesn't change anything when it first boots up. I don't mind it because it tells me that it's booted up, but when it first goes to whatever note it's going to, that's a preserved note or voltage output in the EEPROM. What did I break? I broke something. And it's interesting, I don't think, oh, is it a connection here? Let me I'm gonna set a arpeggio playing so when it works we'll know. So that's to ground. It's still connected there. Oh, you know what? Let me just check the... No, that's just the potentiometer there. What'd I do? This would be a good time actually to look at the output of this. So what I'll do is let's unplug this and just bring this over to the computer, and I'll show you what messages it's getting and how it's converting those to voltages. So let me go to this little view here, And let me find a USB-C cable. Set a weight on that cable so it doesn't fall. And let's see, if we open up the code on there, make sure that's all still healthy. Nope. Let me unplug that Metro M0. There it is. And I'll open up a little serial connection to that. Screen dev TTY. Okay, so what I need to do is send USB MIDI messages to the QT Py, and then we'll see what it does with those. So in order to do that right now, I'm just gonna, in the background here, I'm gonna launch MiRack and tell it to send some notes out to the MIDI port on that. This MiRack will act as a USB host. Let's see, should I share that? No, I'm not going to attempt fade. So let me just create a MIDI CV to MIDI. Output device will be my QT Py. And let's do a sequencer to that. I think this will, there we go. So you can see from the output now, I just have a sequencer that's sending the same note. It's a MIDI note 60. So if I drop that down into the allowed range, and let me just set like 4 steps on here. By default, a lot of these MiRack and other modular things have a 10 volt range. It's a volt per octave, so they'll send a huge range of notes out. I'm trying to get, oh, there was a 15. Let me set this to 1 step. Okay, so wow, that's touchy. Yeah, that's acting better. Okay, so I'll send that, and let me make a 2-note range. Okay, so that works pretty well. So now you can see, I'll slow this tempo down as well. When it receives the MIDI note 15, that's sending 1.25 volts. And when it's at 22, that's sending almost 1.8. Let me add one more note to the sequence. And that'll send 0, which is 0 volts. And then I'll add one more at the top of the range, which I think, if we look at my code here, I am allowing up to 31, MIDI note 31. This would be easier to dial in, except I'm dialing in a voltage knob and not actual MIDI notes. Set the tempo higher. There we go, there's a 32. Oh, I've overshot it. 39. 35. 32. Still 32. 31, there we go. Okay, so that's my top that I'm saying, 2.5 volts. So let's take a look at how this works. You can see it getting notes and then sending out those voltages over the DAC there. And the way this works is I have the driver chip, MCP4728 for the quad DAC. I'm importing that, and I'm importing MIDI as well as MIDI note on and note off. And that is purely for listening. So this is not sending MIDI out, it is just receiving MIDI and then turning that into the DAC values. So then I set up the Stemma QT board there over I2C, instantiate the MCP4728, And then I'm setting the DAC range to from 0 to 4095. Then here's one of, there's a couple ways to do the setup, but I'm setting up this raw value as the maximum range there. I'm using the internal reference, and then I am setting that to a gain of 2. And so the internal reference is, I think, a 1 volt reference, so I'm doubling that. So I have a 2 volt reference against which I can control those values pretty precisely. I think this is also temperature compensated, so that's way more trouble than I should be going to for tape playback, which is already a bit imprecise and funky, I think. So I might try the other method, which will give me the full 3.3 volt range. Then I have this, each semitone is a 0.833 volts, which probably would work if I'm sending these out to a voltage-controlled oscillator. But for the tape thing, I might need to mess with those numbers to get real semitones and just tune that by ear. And then I have a little function I created here, this MIDI to millivolt. So it takes in a note, a MIDI note, like let's say note 10, and then that is, the millivolts are 1,000 times the note value times the volts per note, which is this 0.833, and that returns an integer. Why am I doing an integer? I can't remember. Is that what I want? Yeah, I don't really want millivolts. I want the 12-bit value to come back. This you can ignore. This was just when I was testing. I was sending it some little melody. I set up MIDI here, which is standard MIDI setup for USB. And then this is the main loop. We listen for a message with this MIDI receive variable. Then if the message isn't none, because that's a possible MIDI message to receive, that a clock is ticking along, but we're not getting any notes. If the message is a note on type message, based on how the library works, I'm just printing it out. Note is this string conversion of that number. And then if it is a note that came in and it's less than 32, the range that I want to use, 0 to 31, then I run that little function, millivolts, MIDI to millivolts, and that gives me message.note, or rather I'm inputting that note into it. The output is what's printing down here, and then that same value is what I'm sending over to the DAC. So I think that's 12-bit value. Rest here is just me messing around with other stuff, so I'll get rid of that. And that's the basics of how it works. So I don't know why I broke it, but let me unplug this and go see if I can make it work again. That's actually the first issue I've had with it. Once I got it working, it's been pretty rock solid. So let me see if I can maybe reboot some things here. I'll turn off the keyboard and let's plug in the Cutie Pie. Plug in my, and I'll open this back up if it's not working, because maybe I just pinched it or something, pinched the wires. All right, I'll play that. Now I'm going to plug in the keyboard, which shouldn't send any message just on its own. And then this keyboard, I've got to drop it down, since it's just this sort of 2-octave range, I've got to drop it down to the range that I want to use. Oh, it's working now. Maybe it was rebooting made things happy. All right, so there it is, pretty neat, pretty nice and neat, closed up largely there. And then I'll turn on some nice effects. And I can put my mic over there. I never asked if you could hear this very well. Oh, something just ran out of batteries or happiness. What just died? I've angered something. Oh, the tape player finally ran out of batteries. I knew this was going to happen. But I have some spares. Sorry about that. Yeah, those are some double A's that have been going for a few days. And I've been doing a lot of rewinding, which probably the motor doesn't love. So let me connect back up here. Oh, and I've got a weird, sorry, I got the wrong camera over here. There we go. Something just ran out of batteries or happiness. That's the quote, Mr. Certainly. All right, so let's pull those out. Yeah, this is why I really should put a 3-volt DC source in this. What do I have? I don't even know if I have any barrel jack to 3-volt. That would be a nice one to add. Lamore's been getting these USB-C to power delivery voltages, but I don't think 3 volts is one of the allowed ones there. Oh, it might not have been batteries. It just ran out of tape. It stopped. Maybe these batteries are still good. That was just the tape coming to the end there. And it wasn't obvious. One thing I could do on this just to make it a little cooler looking while I'm showing it off is remove the door. Usually you can get away without the door on these, and then you can see what's going on with the tape a little better. Makes it a little more photogenic. Yeah, that was all that happened there. Okay, so let's show you what I got on here. This module here, which is a effects, digital DSP effects, is being fed voltage from another one here, which is a little voltage recorder called Ephemera. And that's just adjusting, modulating one of the parameters. But that'll sort of track, the effect at least will track with the pitch, which is neat. You could, of course, also send MIDI to CV to these kinds of gizmos. They're all living in the same world, basically. Also a comment that I saw, let me turn this down a bit and turn my AC back on so I don't melt. Over in the Discord, someone, I think Todd and OK You're On, were saying, oh yeah, since you got a quad DAC, you could do polyphony. You could have 4 tape decks, play notes, and have the MIDI hub send notes round robin style to each of the 4 DAC channels, which is pretty cool. So you could have sort of a type of polyphony, or paraphony, I think that would be polyphony, based on having 4 DACs and a keyboard that's capable of sending multiple MIDI notes simultaneously, which is really cool. All right, I will stop that now. I will stop the tape player so it doesn't just keep going, but my assumption there was batteries, and that was wrong. And I think, Toddbot said it's hilarious that I'm adding fake DSP tape warble to this tape audio. This tape player is not warbly enough. I don't know what to tell you. I mean, I could probably do that in code by sending like a little low frequency oscillation instead of telling the DAC to send a locked in note. We could probably have a little fluttery thing. That would be kind of cool. Let's add flutter and wow. Flutter and wow. Very cool. So anyway, thanks for hanging out and allowing me to dive into some tape stuff. It's loads and loads of fun. You can, generally speaking, pick up one of these cheap players. I'll show you, I don't know if I showed a link to this, but the one that I'm using is, let me just look for GE35362 tape player. Looks like that right there. You can find them in eBay. Here's one for 20 bucks. I think I got mine for 15 or something like that, or maybe even 10. I think I did an offer. Just look for ones that say they work. They've been tested and work. Or if you want to try your hand at the modern, more recently manufactured one, which I'll tackle next. That is the Byron Statics right there. If you Google around for this, there are quite a few people online who've been doing some neat hacks with this. And I'll put some credits to some people whose work I've checked out. I'm blanking on names right now, but there's a few people who've done some cool hacks with this, including one maker who hacked that little micro USB port off of the circuit board or tapped into it to run the QT Py, put a QT Py in a DAC or a digital potentiometer in there where the batteries were. And I think maybe powered it all via USB as well as the QT Py, which is cool. And my apologies for forgetting names right now, but I'm still slightly jet lagged. That's my excuse. All right. I think that's going to do it for today. So thanks for stopping by over in the YouTube as well as in our Discord chat. And I will be finishing up an article or a learn guide on my 8x8 MIDI Neotrellis, and then I'll be doing a guide collaborating with Liz on a couple of ways to do some of this tape hacks. Let's see. Dexter said, what if we did a one-off community project box with all in-stock components? What's that in reference to? The tape thing? Or something else? I'm not sure. All right. Thanks, everyone, for stopping by. For Adafruit Industries, this has been John Park's Workshop. I'm John Park. See you next time. Bye, Lars. Beep, 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 beep.